Shoot. Okay, so now we can talk about the quizzes. So again, suppose you wanted to conduct a study of the depth of clarity of Lake Tahoe by selecting 40 locations in the lake. Explain in detail how you would identify the 40 locations using the following sampling techniques. So stratified sampling. What just happened? Okay, so start out with stratified sampling. Who remembers what stratified sampling is all about? Hopefully all of you, because you're just quizzed on it. Do you remember how stratified is?
I can answer that.
Mm-hmm.
So what I said is you have to divide the lake into groups proportionate to the population being the lake.
Yeah, what does it mean to be a population though? So I want to be specific.
Population would be the body of water, I guess.
Yeah, so we have to identify strata that would probably be important. Does that make sense?
Yeah.
Okay, you're right in terms of that. That's the definition, but now we have to understand what it really tells you to do. So we want to think about what different types of things in Lake Tahoe might change clarity depending on where you are in Lake Tahoe. Does that make sense? And any thoughts on something that might be important so that you could eliminate some bias?
Areas that might be most visited, like a beach.
Okay, good. So what we're going to do is we're going to break the lake up. I have to underline, but and let me write 1 because we're doing stratified. Break the lake up into areas based on how often they're visited. And again, this is a quiz. You don't have a whole lot of time. We'll leave it at that. But how often might be how many boats there are, for example, because that might affect clarity. Okay. Then with stratified sampling, the next thing you have to do is you have to do some research. And you have to say what percent of each of these areas, or are each of these areas, I guess is right to say. So then research the percent of the lake for each of these area types. Does that make sense, or is that confusing? Okay, so we're going to say there's like some areas in the lake that on average have maybe 10 boats a day. And then you're going to say, well, what percentage of the lake has an average of 10 boats per day? And you might do some satellite pictures. I don't know, somehow figure that out. Again, there'll be other areas of the lake that maybe only have 1 boat per day. Somewhere right in the middle where the boats never get to, basically. And you're going to find out what percentage of that, et cetera, et cetera. Then you multiply. The percent by the number of, and what we're doing again, we're checking for lake clarity checks we want to do. Okay, so that's establishing the quotas. Then make sure that those numbers are what are the number of each type you check. Any questions on stratified?
Just one question.
Mm-hmm.
So for the groups, they have to be proportionate. The samples you take from the groups, are those random?
They don't have to be.
Okay.
They don't have to be. You're trying not to have much bias, so you're not going to go and try and do the least clear ones you can find. You're just going to go and pick some. And the idea is random is, I don't know if you remember last time, but you should always be worried if you even say you did it random, because it's very hard to do that. So just saying, are they random? Good luck. Okay. Now, there is a way to do random on this one, which we'll see on number 3. Okay, but for a lot of times you can't. So they don't have to be random. We're doing stratified sampling, which means you have to make sure that you've identified maybe the number 1 bias or maybe 1 and 2 bias, and then make sure you establish quotas so you don't have that bias. And that's what stratified sampling is. Okay, let's do cluster sampling. Who remembers what cluster sampling is? Okay. Someone said, what do you do to get a bad grade on the quiz? Well, it's very easy to get a bad grade on the quiz. You don't do anything. If you leave it blank, you'll get a bad grade, I promise. But maybe that's not what you really meant. Maybe you meant, what do you do if you got a bad grade? Is that possible? I was going to ask that too. Yeah, I think you meant, what are you going to do if you got one, not to get one? Because like, to get one is pretty easy. You don't want to do that. So the first thing is that the quizzes are not that big a percentage of the grade. So definitely don't drop the class if one quiz you got a bad grade. What it really means, if you get a bad grade in the quiz, that means that you should go work with Anna or me and make sure that the things that you didn't understand, you understand before the exams. It's the exams you don't want to get a bad grade on, because that's where most of the points are, and the projects. So that's just a note in terms of the quizzes. Quizzes, we call these, I don't know if you've ever taken a course in education, but we call those formative assessments. Formative assessments are assessments to help you decide whether you've got it or not. Whereas the exams are called summative, and those help me to decide what your grade should be. So the quizzes are to help you decide whether you've studied enough. Does that make sense? And practiced enough. And if you didn't get the quiz well, then that's where you get help. Okay, and maybe put some extra time in. Does that make sense? Okay, so that's why there's lots of quizzes and only a few exams. So you've got lots of chances to see whether you're getting it or not. Okay, let's do number 2. So cluster sampling. Who remembers what cluster sampling is? It's all quiet. Well, maybe I'll just tell you. So cluster sampling means that we organize into clusters. And I think the most natural clusters here might be areas. So in this case, you might want to just do a grid, okay? Maybe in the grid, you might want to look at shallow areas, deep areas, middle areas, and you're going to take a grid, and then it's very easy to grab a map of Lake Tahoe. You can do that with Google. You can put a grid in there, and maybe have 1,000 different areas of Lake Tahoe. Lake Tahoe is very big, so you can do that. And then what you're going to do is, so let me write this down. So first, make a grid. I guess put instead of make. Put a grid onto the map of the lake. Okay. And then what we're going to do is we're going to select a representative number. Okay. And I think I'm trying to remember if I told you how many you had to sample. Let's see, 40 locations. So maybe you're going to select 4 different locations from the lake. Okay, actually, let me write grid areas from the lake that are representative. Okay, and again, that 4 might be these huge areas, Then out of those 4, for each of those 4, conduct 10 tests for clarity, and that gets your 40. And that way you don't have to vote as much. You just hang out, do a little clarity check, maybe go 10 feet away and do another clarity check, do that for 10 different times, and then go to the next area. And that's easier in terms of less logistical issues. Does that make sense? Okay, let's look at number 3. 3 is random sampling, which is very difficult. Okay, so for random sampling, there aren't very many choices on this one. So again, you can get a map of the lake. And let's say you have a nice camera, and in the camera, it's got, let's say it has 10 million pixels. Okay, list every pixel as a number. So in other words, you order them as pixel 1, pixel 2, pixel 3. Then use a computer to select 40 of these pixels randomly. Computers do random, no problem. Then measure at these 40 locations. Any questions at all on random? Okay, this is one case you can probably do a random because you can do that. You could list the pixels. You have to do some, computer programming probably to do that, but you can imagine doing it at least, and that's good enough. Okay, now convenience sampling. I'm hoping you can all tell me how you do convenience sampling.
Taking a boat tour around the lake and just sampling.
Yeah,
Like,
take a boat tour. I like those words. Around the lake. And sample when it feels good. Okay, no scientific anything on that. Is that clear? Okay, and those are the different sampling techniques. Any questions on this example? Okay, let's answer question 2. Okay, suppose that you're interested in better understanding, sorry about the typo. It should say how children are learning, not how children are learning. Okay, academics, in these times of school closures, at the stay-at-home rules. I don't know if any of you are dealing with that right now. Any of you have kids that you have to be their teacher and you are not used to being their teacher. But I know a lot of people are doing that right now. Okay, come up with a survey question such that the variable is, number 1, quantitative, number 2, qualitative. So hopefully you remember, when we say quantitative, what does that mean?
We're looking for a number.
Yeah, it means the answer to the survey question is a number. So we're going to write down the survey question, and then you're going to think about asking someone, and then a number better come out of their mouth. Do you see that? So if we want to talk a little bit about how children are learning in these difficult times, what might be a survey question that's quantitative? Any suggestions? There's lots and lots of good answers, by the way.
How many hours did your child do schoolwork each day this week?
Okay. So how many hours this week Did your child do schoolwork? I'm going to write on average because you said each day. If you don't say on average, then 7 different numbers are going to come out of your mouth. Does that make sense?
Mm-hmm.
Any questions on question number 1? Okay, and then I asked you to do one that is qualitative. What should not come out of the person's mouth when they answer the question?
Numbers.
Numbers. So any suggestions on a good survey question where they're not going to answer with a number?
What type of online tools is the school implementing for the classes?
Great, great. Any questions at all on the quiz? Okay, I just want to let you know, this is the first quiz, but this is a good representative quiz. I'm going to quiz you more on more of the wordy kind of answers than I am on the calculations. And the reason for that is when do you do the calculations? When you tested on the calculations or quizzed on? Some of you probably know. You don't know? That's on the homework assignments. So you've been doing lots of calculations in the homework assignments, whereas a computer is not able to grade a question like this, but I can. Does that make sense? So this allows you to practice these kind of questions, which are asked on the exam, as are the calculation questions, so that you can get used to both types. Any questions at all on the quiz before we move on? Okay, let's move on. And what I'm going to do now is I am going to move to my spreadsheet program. And I want to mention a few things. And I've been working on this a lot, trying to figure out the best way to make this work. Because we're in a new situation I have never dealt with before. And that is dealing with the fact that we're not allowed at the college or at any proctor center, or basically you can't talk to anybody that you don't know close up. It's a little sad. Firstly, I'm not coughing much. Maybe I'm getting better. We'll see. But so the idea is I can't give you a proctored test with people. The test is going to have to be done on the computer because there's just no other way to do it. So in particular, there's a computer proctoring software program that the college has called Proctorio. Anyone ever heard of that before? I don't see y'all jumping in and saying yes, but there's a software program called Proctorio. What it does is it watches you. So you need to have a camera, and if you don't, you need to go to the college and get a computer that has one, and they'll give you one. Okay, they'll give you one. You got to give it back at the end of June. And it watches you to make sure you're not looking over and stuff like that, or getting your phone out. And what you do is you do the whole test on the computer, and it watches the computer and makes sure that you stay on the test. So you can't go and email your friends. And what I'm going to do is but in order to do statistics, we have to have the ability to crunch the numbers, not by hand. So what I'm working on, I'm about 90% sure this is going to work. We'll find out for sure soon, is to get the spreadsheet program embedded into your test. So this is brand new. It's never been done before, but I think I can do it. I'm a programmer and I think I can make this work. It's going to be slightly different than this. It will not be Google Sheets. It'll be on something called LibreText, but basically we're taking this and putting it onto another platform. So what I recommend is get acquainted with this program so that when you take the test, it won't be the first time you're doing it. The good news, and I'm not just saying it because I wrote it, But the good news is there's very little learning curve for this. Okay, there's very, very little learning curve. It's free to everybody. And it's, but give me a yes if you have used Google Docs before, and a no if you never have. Okay, and use mean even red one. Okay, so most of you are saying yes, some of you are saying no. So this is Google Docs. Okay, it's actually, it's a Google Sheet in Google Docs, basically. And I can do what's called share it. And I can copy the link. This is also in the, it's on Canvas too. And there's a link, you now have it, and you get your own copy. And that way you can practice with it so that you can know how to do this before a test. Okay, but I promise it's not that hard. Okay. So what we're going to do is we're going to play around with this, and I'm going to do some surveys. Okay, let me ask you something. By the way, today is about quantitative data for everything we're doing today. Is there anything you're interested about hearing or learning about each other that's not too private, you know? So don't ask something like, you know, how many times have you cheated on your boyfriend or girlfriend? That's a little too private. But, you know, things like how many siblings you have, you know, things like that where most people are fine with. Any suggestions, and we'll do it. Any curiosities you can put in the chat box if you're curious about something, and we'll find out. Okay, so let me make that quantitative. Definitely not what's the name of your pet, but how about how many pets? And we're gonna we had to define it. And by the way, this is hard in statistics to come up with the survey question so you ask really the right question. Because if you asked me how many pets I had, that's a little complicated because it might be over 50. If you count my fishbowl that I once had, little goldfish swimming around that tank. So we're gonna go dogs and cats. Sound good? So in your lifetime, how many dogs and cats have you lived with? Or have lived with you? You can look at it that way. So put that in your chat box. And this isn't a test, so just guess, you know, an idea. You don't have to like try and get the exact number, especially if you're old. So in your lifetime, how many have you had? Okay, total dogs and cats. Okay. All right, what I need to do is I got to scroll up so I can actually put these numbers in. So what I'm going to do is in this first column, that's column A, I'm going to put all the numbers in. We have a 2, we have a 1, we have a 2, 8070. Then it's more 119438. Yeah, I'm really glad we had Michelle in this room because it's going to help us later. Then 7, 8, and 3. By the way, did that look hard? Hopefully that didn't look too hard. Okay, just to let you know, and I think I showed you last time too, if you're doing your own, the very first thing you ever have to do, and you'll have to do it once in your lifetime, is go to File, Make a Copy. Give it a name and hit OK. If you don't do that, then you won't be able to edit anything. Because what I do is I want to make sure that you guys can't change anything and like ruin it for everybody. And so this is all your personal copy. Okay, so we now have our data entered. What we want to do is we now want to analyze this data. Okay. And what we're going to be thinking, Won't let me make a copy. Really? So you went to File.
Yeah, so I went to File, clicked on it, and everything's grayed out. I can't click on it.
What might help, do you have a Google account, like a Gmail account or something like that?
Yeah.
So log into your Gmail account and try again.
Okay.
Sometimes you need to be logged into your account. And I've learned that almost everyone's got one. If you don't, they're free. You don't have to use it for anything except this, so no one's going to look at you or anything. If but it's really nothing. But most people have one, so that's sometimes the way to make it work, and it should work. Okay, so what I want to do is I want to look at a few things. The first is the histogram, and I'm assuming that you've all seen a histogram in your lifetime. Okay, it doesn't mean you know all the details of it, but you have seen the idea of a histogram. And we look at this histogram, and I want to talk about what does this histogram tell us? Okay, first thing was when you look at the histogram, I want to see what does it tell us, what does it not tell us, because there's both going on. So we see this, and what do you notice about the bars? So hopefully you know how to read this. What this means is between 0 and 8, there were 9 people in that category that have between 0 and 8 pets. And then there were 4 people that had between 8 and 16 pets. And then there was 1 person that had between 32 and 40 pets in their lifetime. Is that clear? But I want to mention something else. I want to talk about what's called the distribution. The histogram is very good for a visual on the distribution. So this particular histogram, we're going to call it skewed right. Okay, this is called a skewed right histogram. What that means is it starts high, and then to the right, it has a tail that's low. Okay, and that's definitely what this histogram is doing. Any questions on that idea? Any guess on what it might mean to be skewed left? Any thoughts? Yeah, it starts low and then moves up high. You could say the high point is on the right, and the tail, the low point, the low areas are on the left. Okay, so that would be if it was skewed right. So there's different kinds of statistical terminology or vocabulary for understanding the various shapes of a histogram. So this one is definitely skewed to the right. Okay, definitely visually, it looks like there's what we call an outlier. And we'll have towards the end of today, we'll have a mathematical definition of outliers. But right now, I just want to give you a visual on outliers. So an outlier is a value that is far from the rest of the values. So it's either far left or far right. And we can see that there is this one value. That's why I was really happy that we have one, because then I could talk about it. Okay. Yeah, like I said, if I asked dogs and cats, if I asked for all animals, then all bets are off. Because people have all kinds of interesting pets. But if I got dogs and cats, no one's going to be 1,000. So this is definitely an outlier. Okay, or at least it's visually an outlier. Definitely we can't know yet, but we'll know soon. Any questions so far? Okay, so that is a very important plot. Here's what it doesn't tell you. If I looked at this and all you didn't have the data, all you had was a histogram, and I said, based on the histogram, how many people have 4 pets or have had 4 pets? Could you tell me? Could you look at that histogram and tell me how many have 4 pets? Yeah, you couldn't. Okay, so one of the drawbacks of a histogram is that you can't get individual data values. You only get ranges. Is that clear? So that's a problem with the histogram. One of the good things about a histogram is just about everyone knows what a histogram is. So if you're giving a presentation, let's say you're giving a presentation to your company, and your company is not a mathematical company. I don't know, maybe you sell clothes. I don't know if you're even allowed to do that nowadays, but let's pretend you're allowed to sell clothes. And you gave a presentation to the employees that are, you know, salespeople and clerks and all that. Then most of them could read this and understand it. Do you agree? This doesn't involve some kind of high-level statistics at all. Doesn't need this class. Almost everyone gets it. I want to talk a little bit about some other distributions that could happen, okay, that this isn't. So first thing is this distribution is not symmetrical. Anyone know what symmetrical means? You can say it or put in the chat box. Even, it's kind of a good word. Okay. Yeah, left, I like left equals right is better than left plus right. Yeah. Highest point, actually the highest point doesn't have to be in the middle. You could have symmetrical where you have a tall left and a tall right and a small center, and that could be symmetrical. I like Frank's idea is mirrored. So you can think of right in the center, you can think of it as a mirror and then it works. And that's symmetrical. Okay, so that's another statistical word that we need to understand. Another one to look at this, and this histogram is, and that's called unimodal. Okay, what does uni mean? UNI. That's a prefix, there's a prefix of that word, and you've seen other words with that prefix that you might know what that means. Yeah, one. So unimodal means one mode. And the mode, this you get in 4th grade, which means you probably forgot already. It's been a long time for y'all. Anyone remember what the mode is of data? Again, it's been a while. Yeah, it's the most occurring, it's a data value, okay? And with histograms, it's the data interval with the highest frequency. So this particular histogram is unimodal. Do you see that? Because there is one bar that is higher than all the rest. Is that clear? And that can happen. Okay, so unimodal is a word that can describe. What else? What? Any guess that's kind of related to unimodal? Another word that you might use instead of uni? Yeah, bimodal. Okay, and what do you think bimodal means? Two common points, not quite. Two somethings, two high intervals, two high frequencies. That means there's two frequencies that are high. So let me give you an example of bimodal distribution. Okay, a bimodal distribution, if I did a survey of, let's say, 1,000 different American adults and asked how tall they were. Okay, what is their height? Why do you think that might be bimodal? There's a reason. That will be a bimodal distribution. How come? Yeah, men and women. Okay, because men average around 5'10", women average around 5'4", and you can get modes at both of those areas. You see that? So that would be an example of a bimodal distribution. Often when you have a bimodal distribution, it means that there's really two groups. So like in people, especially for heights, there's men and women. And sometimes when you see it's a bimodal distribution, it's a good idea to actually separate the two groups out and do a histogram for each of them. Any questions on that? Kind of like looking at the chart and then making some conclusions based on it. Okay, so another distribution that's important is what's called uniform. Okay, when people have to wear a uniform, that might be in the military, maybe in high school, what does that mean? Why are they wearing a uniform? What's the reason? Yeah, they should all be the same. Okay, so a uniform distribution means everything's the same. So what's it going to look like? What's the histogram of a uniform distribution going to look like? Yeah, it's going to be flat. So let me give you an example. I'm going to get rid of these and we'll get them back, by the way. The nice thing is I can control X. Let's do it again. And let me give you whoa, that wasn't supposed to happen. Oh, I know why it happened. I have to go down there. Okay, there's a uniform distribution. So it looks pretty flat. Okay, so it's very easy to visually see that it's uniform. And by the way, you're going to be responsible for all these vocabulary words. So take notes, write them down. They're also in the book. Any questions on what a uniform distribution looks like? Just want to get back to our data. Okay, so that's a uniform distribution. And there's our data for a uniform distribution. Let me give you one more distribution that's important. And I think I'm going to have to go and just Google image it. And that is normal. Get it? All right, so here's a bunch of images. I love Google because I don't have to draw it. There it is. So these are a bunch of images that are all normally distributed. Okay, and that, it turns out, it's not obvious today at all, is going to be the most important distribution for this whole class. So you got to just trust me on that one. Where have you seen this distribution? Where have you seen this shape? I'm sure you all have, because you haven't been stuck in your house for your life, not like we are right now. COVID, I think you meant COVID-19. Actually, it turns out COVID-19 is not quite that. It's actually parabolic. Roller coaster, okay. News, it's on the news every night. Let me give you a happier example. Anyone ever been to the beach? I hope you have, because it's nice, whether it's the Tahoe Beach or the beach in Malibu or whatever. If you drop sand and you look at the shape, that's the shape. You all seen this before? Okay. If you haven't, go to the beach because it's beautiful. I think you're even allowed to now if you live in Tahoe. Just stay away from other people. So this turns out to be a really, really, really important distribution. And all we're going to do now today is say, this is the shape. And you can look at it and say, yeah, that looks uniform. Any questions on that? Okay, so let's get back. So now we've talked about the histogram and some distributions. I want to show you some other kind of charts. And let me start with the stem and leaf chart. So now if I go to stats and I go to stem and leaf, Okay, and this is an example of a stem and leaf with the outlier taken out. Sometimes it'll do that. Okay. And so this is a different kind of chart, but it gives good information, different information than the histogram. So the first thing is what it does is it breaks it up. And what happens is the left-hand column are the tens digits, and the right-hand column are the ones digits. That can be changed. But for this example, that's what it is. In most examples, that's what it's going to be. So then what we can do is we can say, let's look at, say, how about this number 4? So that means 0, 4. Whereas this number 1 does not mean somebody said 1. That means someone said 11. Any questions on that? So one of the good things about the stem and leaf is it allows you to go back and know all of the data values. Do you see that? So we could see that 2 people said 7. 1 person said 11. 2 people said 8. Okay, and then it says outliers. 1 person said 38. By the way, the bottom part is so that it's accessible to those who don't have vision, and then a screen reader will read it. So you don't need to look at that very bottom stuff, unless you're blind, and then you do need to hear it. You won't look at it anyway, but you'll hear it. Just to note, that's how I programmed this, so that it's accessible. So one of the good things about stem and leaf is you can actually look at it and know exactly what all the values are. You can get them back. What are the cons? What are the problems with the stem and leaf? Any thoughts? There's 2 major problems. Any thoughts on what a problem is? Why it's not always the best thing to display? Any thoughts? Because it's kind of like a histogram, but it gives you actually more information, right? I'm not hearing any answers. Okay, well, maybe I'll fill you in. One is that imagine doing a presentation. Let me do the example again where you're going to some kind of clothes store. You're looking at the employees that work at that clothes store. You want to present that and show this to them. What's the problem with that? What's the problem with showing people there? It's a bad visual, but even more, no one's going to understand what it is. Histograms, people know how to read. People don't even know how to read this. Do you agree? Again, most of you probably, until I showed you right now, had never seen this before. So if you present this to a general audience, they will be totally lost. And that's a bad thing. Okay. Another problem is it doesn't show in this particular example, but imagine you wanted to do a graphical representation of, let's say, the heights of everyone in the United States. Why can't you use a stem and leaf? You have to calculate for the mean average. You don't need to calculate it. 1 digit. No, if you do in inches, most people are not 1 digit in inches. Some people are, I guess. You could be born at, infants maybe. But most people have multiple digits. Okay. How many people are there in the United States? Around 300 million. You'd have to have over 300 million digits written on your paper, and it doesn't work. Is that clear? So this only works for not so large data sets. This does not work for giant data sets. Yeah, if it was a sample, but I said everyone. I didn't say sample. Yeah, if you had a small sample, that's fine. But if you want to do everyone in the United States, forget it. So if you had, your population size or even a sample size of 20,000, forget it. You can't do stem leaf. You can do a histogram because that just has a y-axis and you can write down a 10,000 on that y-axis. but a stem and leaf doesn't work for that. So the two problems with stem and leaf are most people don't know how to read it. So it's not good for general presentations. And the other is it only works for a reasonable sample size, okay, or population size, depending on what you're showing. Any questions on the stem and leaf? Okay, let's go to the next one. And before I do that, I want to go to statistics. Okay, so I want to go through and I want to look at the statistics. And what I've tried to do is I've tried to make the spreadsheet really easy. So hopefully, does that look easy to put in the data? Hopefully that was easy. Again, I'm biased because I wrote the program, but all you do is type the numbers and hit enter. Okay, then what you need to do is you need to look at the statistics. And I tried to make it obvious. Can you tell me what the smallest number is? Just from looking at column D, that's a hint. In fact, let me do that so you can't even look at the data. Yeah, 0, because that's the minimum. And I'm hoping you all know the word minimum, the smallest number. Okay, and then the mean. Remember the other word for mean? I talked about that a couple days ago. Yeah, that's the average. I want to mention something that's pretty important. The spreadsheet gives many, many, many digits. Do you think that number of digits is reasonable for any application for this example? Because it's 7.461538462. What do you think? If you were to give a presentation to like a large group, yeah, that you wouldn't do that. Okay, you would probably do maybe 7.5. So you'd say the average number of pets people have is 7.5. That's the mean. Is that clear? So I want you to be able to look at a number and then round it to a reasonable number of digits. Had this been instead of number of pets, had it been money, you might want to go 2 digits because that gives you dollars and cents. Okay, so that's something that you have to learn how to do, is come up with reasonable rounding. On the computer homework, it'll tell you how many digits to round. You need to do that. Okay, sample variance, we're not going to be doing in this class. So if you put it in your project, for example, I'll probably take off points because you shouldn't even talk about it. On the other hand, sample standard deviation is really, really important. Okay, so that is the mean and the standard deviation. Those are the two most important statistics in this entire course. So pay attention right now because you need to know what those are. Okay, the first thing is what you don't need to know is the formula. Okay, there is a formula. It's a square root of the summation of x minus mu quantity squared over n minus 1. Don't worry about it. Pretend I didn't say it. What you do need to know is what this means. So this sample standard deviation, I'm going to round to 10. It's about 10. It's kind of an average distance from the mean that the data values are. So our mean was about 7.5. Our standard deviation is around 10. So that means that most of the data is going to be somewhere between 7.5 minus 10, and so we're talking about number of pets, just go 0, to 7.5 plus 10, which is 17.5. So that, just from looking at this, you can say most of the people have had between 0 and 17.5 pets. Okay, so it gives you an idea of where the data values lie instead of just what the average is. So let me give you another example. Not this example, but a different one. I'm going to tell you, so see if you can remember. What score or what percent do you need to pass this class? See if you remember. That was 2 days ago. I went over the syllabus. See if you remember. What's the passing? Yeah, 70. Okay. So what I want is I want a lot of people passing. Okay. That's what I'd really like to see happen. Okay. What if I told you that the average or the mean score for the course score last quarter when I taught statistics was 73%? What do you think? Do you think I've succeeded or do you think I haven't succeeded? So what do y'all think? Okay, we got an ouch and we got a succeeded. It's interesting. You're definitely not agreeing. All right, so this is a trick question. The answer is you can't tell me just based on the average. Okay, on the other hand, now let me give you the average. What is the parameter? The parameter is, I said the average was 70, what did I say, 72% or 73%? I think I said 73%. So when you're asking what's the parameter is just, well, are people passing or not? Are we having most of the people in the class pass or not? Because that's what I want. I want most of the people to pass, right? But now what if I told you that the average score was 73%, same thing, but the standard deviation was 0.5%. Now what can you tell me? Yeah, probably everybody passed the class. Because 70% is 6 standard deviations below the mean. You see that? You have to go 6 halves to get down to below to 70% from 73. So that's a lot. Just 1 standard deviation gets most people. 2 gets usually around 95%, and 3 is over 99%. 6 is unheard of, to give you an idea in terms of figuring out what these standard deviations mean. So if I told you that the average score was 73% and the standard deviation was 0.5%, then you would say that it was very successful. Almost everyone passed. You all got C's, but I'm okay with that as long as you pass. You may not be okay with it, but if you're not okay with it, study your butts off so you can get A's and B's. Okay, and if you can want to see, you still need to study pretty hard. Okay, now what if I told you that the average was 73? We'll do that again. So the mean was 73, but now the standard deviation was 20%. What can you tell me? So if the mean was 73, but the standard deviation was 20%, what can you tell me? Okay, now I've given you enough information, actually. All right. There are more A's than F's. That might not even be true. There we go. Austin knows it. A large percent failed. Okay, or at least got D's. A D is as bad as an F. Okay. Now see, the 20% is an average away from it. So if everybody was above 73%, the average wouldn't be 73%. Do you see that? So for everyone that's above, for everyone that gets 90, there's got to be somebody low in the 60s. Do you see that? Or maybe the 50s. So if the standard deviation was 20 and the average was 73, that means probably close to half the class probably didn't pass. And that's awful. At least I think it's awful, and you probably do too, right? Okay. So I want to give you an example of kind of how that works. Any questions on that? So that's the standard deviation. It's very important to be able to see that. So notice the standard deviation here is actually quite large. It's around 10. And notice that the average number of pets is only 7.5. It's even higher than the average. That means people are all over the place. And what really matters is this outlier. This one person who had so many pets makes that standard deviation really go big and also really changes the mean. So outliers really, really affect the standard deviation. whether they're on the low side or the high side, they affect the standard deviation. Any questions on the standard deviation? We'll do more with the standard deviation, by the way, for the entire course, by the way. We're not even close to done. But I want to spend a lot of time on that one. Whereas the rest of them will be quick. The median, who remembers the median? Again, 5th grade, I think. Maybe 6th. Who remembers what that number means? Remember median, what that word meant? Yeah, it's the middle, okay? And technically it's the middle if there's an odd number of numbers. And if there's an even, it's the average of the two middles. Okay, and in fact, our n was 13, we had an odd number of numbers. So that means that it truly is the middle in this case. That means the middle is 7. Okay, any questions on that so far? Okay, notice that the mean is larger than the median. That's what happens when you have an outlier. Outliers pull the mean towards it, but leave the median alone. So here we have an outlier high, so the mean is going to get pulled up, and the median is not going to get pulled up. Whereas if the data is symmetric, the distribution is symmetric, the median and the mean will always be exactly the same. There could be 2 outliers, one on the left, one on the right, but then it's a tug of war, and they both pull the same. Where have you heard the word median used a lot in the real world? Where have you heard it? You've heard it. I'm sure you've heard it. Yeah, home prices. Talk about that. And why do you want to use median? And Tahoe is a perfect example of that. Okay, so what does a median tell you? And why is a mean very different than that in Tahoe? Okay, there's a big gap. In particular, yeah, let's think about Facebook. Who owns Facebook? I bet somebody knows who's the owner of Facebook, the founder. Yeah, Zuckerberg. Now, do you know that Zuckerberg bought a house in Tahoe? I don't know if y'all know that, but Zuckerberg has a house in Tahoe. Bought it last year. Okay. Do you think his house in Tahoe is like my house? What do you think? You're looking at my house right now. Okay. Okay. Zuckerberg's house is not like my house at all. Okay. I have a house that's pretty close to the median house, it turns out. And that's not because I'm a teacher. I'm not a Zuckerberg, I'm a teacher. I'm not ultra poor, I'm not ultra rich, I'm kind of middle-ish. And that's how it could be. I have actually have a lot of financial, extra finances that other people don't have because I'm a mathematician and I know how to play the stock market. So today was a $2,500 day, by the way, just let you know. That we'll talk about later in this class on how that works. Yeah. But I do have a mid-sized house because I bought it a long time ago. So the median will give you the idea of the typical home price. And the typical home price is really important if somebody's moving up here and wants to find out what the community's like. Kind of what are the regular people in the town? Does that make sense? Median is good for kind of the regular typical ones. Okay. The mean, though, doesn't mean the mean's not important. The mean is important for other reasons. Why is a mean home price important? Who cares about the mean home price? The median would be if you want to find out what a typical person's like in Tahoe. But who cares about the mean? Any ideas? Okay, I'll tell you who cares about the mean. That would be the city council. Okay, the city council, right? The person in charge of dealing with the budget. How come? Anyone know why? Any thoughts? Yeah, taxes. And Zuckerberg is going to pay a whole lot more taxes than I am on his house versus my house. So you want to include the outliers. If you care about the outliers, then that mean is much more important than the median. If you want to exclude the outliers, the median is more important. Is that clear? Okay, so that's the median. The maximum, 38. I hope you all understand what that is. Just the highest number. I'm not going to spend much time on it. What I was trying to do, and I failed, well, in the 10 minutes I had just before class actually, was trying to fix this so that Q1 went before Q3, and then I realized all these charts depend on it. Everything got messed up. So I had to revert back. So eventually it's going to change. I'm going to go to Q1 next because that really should be the next one. I realized now it's like, I should put that up there higher. It's much harder than you think to do that. Q1 is called the first quartile. So very important. So the first quartile here is 2. And what that basically means is that if we look at our data, so all of y'all, and we say, well, how many people have had 2 or fewer pets? So we can say that about 25% of the data is 2 or less. So quartile, that's quarters, right? And quarters are 25% each. So Q1 means first quartile, so 25% is about 2 or less. Okay, whereas the median is 50%. Okay, that's such an important thing that we don't call that the second quartile, even though it is. It's really what we call median. First quartile means 25th percentile, 25% or less. What I am going to tell you is it is one of my biggest challenges in mathematics as a programmer there is, period. It is so horrible. And that is, there is no mathematical definition of the quartile. And if you use a TI-84 calculator, you get a different number than if you use a spreadsheet. Pain in the you-know-what. I don't know why there's no agreement in the world on this, but there isn't. What I want you to do is not how to calculate it. I'll never ask you to calculate it by hand, but I want you to understand it. So what quartiles do is cut it up into cut the data into 4 groups. The low, kind of the low middle, the high middle, and the high. And that's what the quartiles do. Okay. Whereas percentiles, you can think of as cutting up into 100 groups. So you have a first percentile, second percentile, third percentile, etc. Okay. So if you look at the first quartile, the third quartile, the minimum, the maximum, and the median, that's 5 different numbers, and we call that the 5-point summary. And it's important and it's used a lot, and because of that, I programmed a box plot. And what that does is it draws a picture of the 5-point summary. Okay, in this case, 7 and 8 kind of get blurred together because they're so close to each other. But here we have the 5-point summary: 0, 2, 7, 8, and 38. And the box plot will give you a picture of that 5-point summary. So one of the main things about the box plot is we can say that the middle 50% of our group has had between 2 and 8 pets. Because this red box, that's the box plot. That's the box in the box plot is what I meant. These guys, the high side and the low side, the maximum and the minimum, those are called whiskers. Those are called whiskers. So often they'll call these box and whiskers plots because you got the box and you got the whiskers. So if when you have to, and you will have to, by the way, explain the box plot, one of the main things you should be talking about is the middle 50%, because that's one of the big things it shows. Is that clear? So box plots are used a lot. What's one of the big problems with box plots if you're presenting it in public? Any thoughts? No data points. Visual's good, actually. It's good to be visual. Visuals are great for presentations. Yeah, it's hard to understand. Okay, most people don't know what a box plot is. Okay, although every 16-year-old does. Anyone know why? I say most 16-year-olds do. And maybe even 17-year-old. Okay, it's have you heard of the Common Core standards? Hopefully you've heard of Common Core for education, right? Yeah, so one of the things about Common Core is they put in a lot more statistics than pre-Common Core. So children actually are growing up with a statistics class. Okay, at least our first 3 chapters, maybe even 5 chapters. So a decent part of this class, all children are learning now. Whereas when I was in school, we didn't even look at a histogram. We didn't do any statistics. Things are different now. So all children are learning. Okay, so we got one person vaguely learning about box plots, and probably you're young. You know, I'm not, you did it to me privately, which means I'm not gonna say who you are, but you're probably young. Yep, a bit younger. Yeah, so if you're under 22, then there's a good chance you might have learned about box plots. If you're over 30, definitely not in high school. Okay, any questions? Let's see at AP Stats, by the way. Okay, so that's box plots, and that's another presentation tool for visualizing data. Any questions on the box plot? Not too bad so far? Okay, so now we've got, and by the way, I'm going to call these the big 3, the histogram, the stem and leaf, and the box plot. The reason why I'm calling them the big 3 is those are the 3 that you're absolutely required to learn in this class. That I'm going to test you on them. They're going to be in your projects. We're going to do a lot with this. There's a lot of other plots out there. One that you all probably know is pie charts. I hope you all know pie charts. Pie charts are great, are for qualitative data because they show kind of in a pie how much of this and that and the other thing instead of numbers. Okay, so pie charts are good for that. You could have bar charts that aren't histograms. So let me let you know about a histogram. Notice the x-axis here. They're numbers. Do you see that? 0, 8, 16, 24, 32, and 40. Histograms must have a quantitative variable. You can't do a histogram with qualitative variable. Okay, you could do a bar chart, but not a histogram by definition. Also, the bars have to have the same width if you're doing a histogram. Otherwise, it's a general bar chart. Okay, so there are a lot of different kinds of plots. There's line plots, there's collie plots, there's, I can go on in different kind of plots, but histogram, box plot, stem and leaf, those are the 3 you need, I'll test on. Sound fair? So make sure you get those down. That's why I spent time today talking about. Okay, so now, just to let you know some more stuff. In the spreadsheet, you'll see confidence level, confidence interval lower, confidence interval upper. You see that? H1, mu naught. That's later in this quarter. We're not going to do that for another 4 weeks or so. But it's in the spreadsheet because we will get to it, but don't worry about it. So don't try to learn everything today. I'm going to go over the things that you do need to know. Okay, same thing with T and p-value, not today. Got it? Okay, we're going to have a whole chapter just on that, but not today. So hopefully you're happy that you don't have to learn everything in one day. Okay, but the one thing we are going to do is we want to look at z-scores and x-values. Let me give you an example. Let's see what you can tell me. Okay, so when I was a kid, when I was in high school, I took the SAT exam. I don't know if any of you did, but I took the SAT. And my daughter did too. Okay, I got on the SAT a 1280 on the SAT. My daughter got a 2060 on the SAT. Can you tell me who did better? Okay, and the answer is this is a trick question. Yeah, it's a trick question. There's no way you're going to know who did better because this should be very obvious to all of you, is that my daughter is younger than me. Okay, if you don't know that, then I don't know what you're thinking. So my daughter's younger than me, a lot younger, like a generation younger. She was taking it a different era. It's not out of the same. The scoring was different. It means nothing to tell you what my score was. Do you even know if I did well on it? If I told you I got a 1280? Could you tell me that I did well? No. Okay. There's no way. Okay. Even if I told you it was out of 1600, that also doesn't tell you if I did well. Because it could be that almost everyone got over 1500 and then I suck. You see that? Or it could be that no one got over 1280 and then I was the king of the world. Do you see that? So even if you know what it was out of, it still doesn't tell you how I did. Do you see that? And similar to my daughter. You don't know how old my daughter is. Actually, I think, if I remember right, someone in this class knows my daughter. So I'm wrong. Some of you know how old my daughter is. She is 25, by the way. But we can talk about who did better. So what you want to do is you want to be able to compare different values from very different things and try to understand that. And there are different ways of making comparisons about how unusual something is. One way is percentiles. Okay, so what I got in the total SAT is I got in the 92nd percentile. Okay, did I do well, by the way? Okay, I did well. Okay, did I do so well, like they're gonna give me some kind of national award, like as like the American special? No, no, but I did well. I went to UC San Diego. It got me into a UC campus. It didn't get me in, I was devastated. It did not get me into Caltech because I didn't do well enough because I was 92nd percentile. Okay. My daughter was in the 96th percentile. Now, can you tell me who did better? Yeah, who did better? Yeah. No. My daughter did better. I was happier because it's always nice when your daughter does well. So I could tell you I was super happy when she did well. My daughter did better. She did the 96%. She did better than I did on the SAT. Okay. Any guess, by the way, where she went? Caltech, here's a hint. Remember, I'm middle class. I'm a teacher. Caltech's expensive. She went to Berkeley. Okay, so she went to a very good university, but less money than Caltech. Caltech would have been painful. Okay, I don't know if you guys are thinking about where you want to transfer, think about that. Is that we have great universities in California that are state universities that aren't that expensive. But if you go to private, it's very expensive, just let you know. So she went to Berkeley because you could know that she got into Berkeley. Okay, I didn't tell you about her GPA and stuff, but at least from her SAT score, she was in the rank of those Berkeley people. Does that make sense? And she did better than me. But now I want to talk about another way of comparing when you don't know anything about the scores. And that is what we call the Z-score. And that's why I'm over here on the spreadsheet. See where it says X value 3, change this? Pay attention. Tell me what that says one more time. Can you read? Type it in a box. Change this. Okay, you're gonna have to do a z-score on your project. If you use an x value of 3, I'm gonna take off so many points. Does that mean you didn't change it? Or an x value of whatever the last thing I put in when you copied this program. Okay, so what we want to do is maybe say, well, what is a z-score for this person who had 38? You see that? So I made this really easy, and I'm just going to type in 38. And the z-score is basically 3. Any questions on that so far? Okay, now let's talk about what that tells you. So the first thing, and I'm going to say it, but it's an important formula, so I'm going to type in the chat box, is that the z-score is equal to the standard deviation, I'll write as d for standard, the value of x minus the mean, which we're going to call mu, and then we're going to divide that by the standard deviation. I'll call that SD. I'll just call it S for standard deviation. That's more common. So again, Z is X minus mu over S, or X minus mu over sigma, whatever you got, that's what we're going to call the Z-score. Okay? What does that tell us? So what it tells us is how many standard deviations are you, or is this value, above or below the mean? So in particular, our person who has has had 38 pets in their lifetime is 3 standard deviations above the mean. Now remember, being 1 standard deviation of the mean is somewhat unusual, not super unusual. 2 standard deviations above the mean, or more than 2 below the mean, that we're going to call an outlier. Got it? So an outlier means a Z is bigger than 2 or less than -2. Got it? Okay, this is actually bigger than 3. If the Z is bigger than 3, we're going to call it an extreme outlier. Or if it's less than -3, because outliers can be on either side. So we do have an extreme outlier of about 3. Okay, and that's this value of 38 is an extreme outlier. Any questions on how to read this z-score and understand that 3 standard deviations are far from the mean? If you're 3 standard deviations from the mean, you're really far from it. Okay, let me go back to the data and let's take a look at the second biggest value and see if that's an outlier or not. The second biggest value is an 11. Do you see that? So I can go down in my spreadsheet. And now I can change it to an 11. Is an 11 an outlier? What do you think? Definitely not. It's not even 1 standard deviation away. Do you see that? 11 is not that unusual. Is that clear? 38 is very unusual. 11 is not. Okay, we can also go to the lowest value, which is a 0. Never having a pet in their life, which is sad. So I'm going to put a 0. Okay, is 0 an outlier? What do you think? Yeah, 0 is not an outlier because it's negative, about -0.8, and you have to be farther down than -2. And -0.8 is not, or -0.75 if you want to read it that way, is definitely not lower than -2. Any questions on reading the z-score and deciding whether or not you have an outlier? Any questions on that? So the z-score tells you how unusual something is. Okay. So let me ask you a question. I'm going to tell you that at Barton Hospital, I'm going to do happy hospital stuff instead of sad hospital stuff. Let's suppose that a baby was just born, and the z-score for the baby's weight at birth was 2.9. What would you tell the mother if you saw her the next week? What would you tell that mother? The z-score was 2.9. Absolutely. Z-scores of weight's really important. And we'll talk about that in a bit. The Z-score can matter in a big way, especially for research. Okay. I don't know if Barton calculates it because they probably don't know what a Z-score is, but researchers do calculate Z-scores. So what would you tell that mother? You wouldn't tell the mother it's a crazy town. Any thoughts? You probably would say, wow, that must have hurt. How come? What does it mean if a Z-score was 2.9 about that baby? Yeah, it was a really big baby. Almost an extreme outlier, definitely an outlier, very large. Does that make sense? Okay, so we got a big baby. In fact, I now have a grandnephew that was one of them. And yeah, it hurt my niece because he was one of these outliers, not an extreme outlier, but an outlier. Still is in size. He's 8 months old, I think now. So that could happen. What if the Z-score was negative 3.2? Now what do you say? Yeah. Now you say this is a preemie, did it live? Okay, so now if a baby is born with a Z-score of negative 3.2, that's an immediate ICU. You guys know what ICU is? Maybe you don't. Yeah, intensive care unit. That would be an intensive care unit baby. That baby's probably not going to live. Okay. In fact, I have an aunt that works with babies like that. She works in Children's Hospital in LA for babies that are in really bad shape. And one of the main reasons why babies are in horrible shape is they're born too small. Okay, so if you have a Z-score that's very small, like negative 3.2, baby's probably dead. Okay, it's sad, but that's reality. So I think we have some people that are interested in nursing and stuff, but that's the kind of stuff that matters, is to really understand it's not the baby's weight as important as what the baby's Z-score is. How does a baby compare to what typical babies are? Does that make sense? Okay, and same thing with almost everything that you're doing, blood pressure, whatever you're doing in health. If you have an outlier, then you got a health problem. Does that make sense? Whether in cholesterol or I had a Z-score of 3.8 cholesterol, of negative 3.8 cholesterol. Do you know what I had to do? They tested it when I was at UCLA, and it was negative 3.8. Okay, they sent me to the emergency room because I was too low. It's weird. You don't really hear of that, but I was way too low. Okay, eat all the egg yolks and cheeseburgers. Yeah, unfortunately, I eat too healthy. But I actually ate more salmon now, so I get the good cholesterol. So that's an example of worry. So definitely in medicine, you got to think about those kind of things. And as they'll do by percentile, and as they'll do by Z-score, and they're both important. We're going to spend more time in this class with the percentiles. And the main reason for that, the Z-scores. And the main reason for that is, remember I told you what are the two most important statistics that we've got today? Pretty much in the whole class. I mentioned a little while ago, about an hour ago. Standard deviation is one of them, and what's the next one? It's probably even more important, but I didn't say much about it because you all know it. The mean. So standard deviation and the mean are the two most important, and the Z-score is how does a value relate based on the mean and standard deviation to the data. So that's why we're going to spend in this class more effort on the Z-score than on percentiles. Turns out it's very hard to do statistics with percentiles. It's very easy with Z-scores. And that, just trust me on that. Okay, any questions about any of this? Any questions? Any questions? Okay, just a note, I always like to double check. So we've talked about histograms. Hopefully you know how to do a histogram and how to read it. We've talked about stem and leaf. We've talked about statistics. And again, the two biggies, mean and standard deviation, you know those. The Z-score is a measurement of combination of that with the value. Then there's the 5-point summary, which is, remember, the minimum Q1, the median Q3, and maximum. So there's lots and lots of statistics. And then there was box plots. Very important for looking at the middle 50% of the data. So that's really important in advertising. Why is that important in advertising? So if you're a business major, why are box plots good to have? Any thoughts? Not seeing y'all jump in. So if you're gonna do an advertisement, you probably want to go to the middle 50% and advertise to them and not worry about the outliers. Do you see that? Because you want to get a broad audience that's kind of that normal, typical people. That's who you usually advertise to. And you want to say, well, what's a normal, typical person who comes into my shop? So in business, that's really important, is to be able to figure out how do you best advertise so that you are targeting the right people. And if you get a box plot of the different things that your people are doing, then you can target to those people. So I have a nephew. I have a big family, by the way. I have a nephew that makes, I think he makes a couple $100,000 a year doing that. He's an AI programmer. And what he does is he creates box plots on everything you do on the internet. He's one of those scary people. And he takes those box plots and then targets advertisements to you. Okay. And he programs the advertisements so that you get, and I'm sure you've seen that on the internet, you get advertisements that gear towards you because you're in that box of the box plot for that particular thing. Okay. I like to say I have a lot of smart people in my family. He's one of them. Okay, not everyone is brilliant, but you know, I'm proud of my family. I'm allowed to be proud. But I use my family as examples because I can. Okay, but we're all stuck at home. Nobody's going anywhere right now. So that's all of us, not just my family, but you guys too. Okay, and then Z-score. So we talked about Z-score. Z-score is especially nice to determine outliers, to find out whether something's an outlier, and it could be the low side or the high side. I thought we'd play a little game, and maybe you guys can play it too. I'm going to show you where it is. Let me go to the textbook. So if you can do this too, go to the textbook and follow along. Let's see how you do. I'll do one of them and then see if you do the rest. You go to the textbook. We're in chapter 2 right now. And I programmed a game. I'm a coder. So if we go to measures of the spread of the data, and again, if you can go to it also, and scroll down a bunch. Okay. By the way, if you want to calculate anything, it's all in here. If you want the standard deviation, there it is. That's how you get it. Okay, so I made a game. And I'll play it once, and I want you to try it a little bit and come back to it. We'll take a little game break, and we'll come back and see how you did. Okay, so the goal is to guess the standard deviation rounded to the nearest whole number. Try to do this visually without doing any calculations. You won't have time to do calculations anyway. You score a point if you get it correct. You don't lose a point if you're within one of the standard deviations, and you lose a point if you're off by 2 or more. Enjoy the game. So let's play the game. I'm gonna click next. Okay, so the question is a standard deviation closer to 1, 2, 3, or 4 for this histogram? See if you put in the chat box, tell me what it is. And then we'll try. I'm going to take whatever the majority is. Everyone should put a number in the chat box, 1, 2, 3, or 4, which you think the standard deviation might be. see. Again, you're not going to calculate, just visually look and kind of remember what the standard deviation is all about. Not seeing you all put in the chat box, but again, it shouldn't take too long because you're just guessing. Okay. So you got a 3, a 1, a 3. Keep going. A 4. A 3. Okay, I think I'm going to pick 3 because we got more 3s than anything else. Let's see what happens. It was 4. Okay, so let's talk about it. Let's see how we can say it's probably 4. The first thing you want to do is you want to go to the mean. The mean of this guy looks like around here. You see that? Around a little more than 4 maybe. Okay, it's not a perfectly symmetric distribution. By the way, if you look at this distribution, it's bimodal. You can see there's a high point on the left and a high point on the right. So it's bimodal. And it looks like the mean is around 4 or so. But then if you look at where the data values are, they're pretty far. You see that? There's a lot that are like around 8. There's a lot that are not pretty close to, there's some that are around 9. There's a lot that are 0 and 1. You see that? So you can see that the values are pretty far away from this. In fact, they're more than 3 away. If you add 3 to 4, you get 7. And that's not really on the right side. That's not where the average ones are. You subtract, you get 1. Okay, and that's close to the average, but it's a little closer to 4 than it is 3. Any questions on that? Okay, let's see if you can go at it. I want you to find it in the book. I showed you again. If you want, I'll show you again. You go to the book, and you can find the book by going to the syllabus and clicking on get the, grab the book. And then you go to chapter 2. And then, in fact, let me go to the book again. So here's the book. You click 2, descriptive statistics. And then you scroll down, and this is a measure of the spread. The standard deviation tells you how spread out the data is. That's why I clicked on that one. Then I scrolled down pretty far, actually. Where is it in there? I think that was not quite that. Maybe it's not that. So it looks like it's about a 1/5 of the way down. And then hit next. So give it a try. Spend some time on this. By the way, now it's different. Notice that this one, by the way, is not that far from being normal. Okay. With random data, and I did this randomly, you're never going to get perfectly anything. So this is pretty close to normal. Someone asked, are the blues zeros? Yeah, so they're small, but they do say 0 if you look really close. I know your screen might be small. You may not be able to see that, but that just means that's a 0 because there's nowhere to put them. So I just put them up high because the bars are 0 height. So I could put it in the middle of a 0 height bar, so I put it up higher. And all the rest of them tell you how many there are. So let's see if you can do them, and let's see how high a score you can get. I'm going to give you a couple minutes to play. We'll get back, and then I'll answer some questions. Again, standard deviation is really important, so I wanted you to spend some time really understanding the standard deviation. So now you're doing that, it gets smaller. And the good news is I have not coughed the whole time. So maybe I just had a little cold. I've told before. And I don't know about you, but everybody's a little scared right now, especially if you're coughing. So I'll give you a minute or two and play around with it. I want you to get the feel for it. That's the whole point. I want you to kind of get the feel for the standard deviation. And don't be afraid to get it wrong. Don't spend 10 minutes on every one of these. Spend a few seconds. Try it, and then eventually you'll get good at it, and you'll get it within 1 every time. So go play. Maybe about 1 more minute. Hopefully you're playing all. Because what I found is if you play this, you'll get used to it and then you'll get a feel for the standard deviation. That's the whole purpose. Okay, shall we take a look? All right, tell me the score you got. Hopefully not all zeros or negatives. 22, awesome. Okay, Austin, that means you're getting it. Okay, so if you can get a high score, that means you've got it. And that's what I'm hoping. You definitely want to go do it until you get it. Okay, anyone else? Again, don't feel bad if you didn't get a super high score, but okay, 3 of 5, that's not too bad. You want a little more practice, but that's pretty good. Okay, take a look, have a list example here. You think it's 1, 2, 3, or 4? And if you're playing enough, I bet you can all get this one. At least within 1. So put in the chat box what you think it is. Any ideas? All right, I only see Austin answering, so maybe I'll try 1 and see. It was 2. So let's talk about why it's 2. Okay, first thing, the mean looks like somewhere between 5 and 6, maybe 6. Okay, if you go 1 away, then that's going to be the 5, 6, and 7. But notice that the 9, there are a lot of 9s, pretty many. And that's pretty far away. Do you see that? So if the mean was 6, 9 is 3 away already. So that's going to pull the standard deviation a bit higher. Okay. Again, you were close, so you didn't lose a point or anything. But it wasn't perfect because it's more like 2. Okay, because if you go to the mean, there's a substantial amount that are 2 or 3 away. Do you see that? If you go to around, 6, for example, there are some 3s, there are some 9s, there's 4s, there are some 8s. Okay, and that will pull it a little bit farther. It's probably like 1.8 is my guess for the standard deviation. Any questions? You got a feel for the standard deviation, hopefully? Okay, so what I think I'm going to call it, we've gone through everything I planned to go through. And what I will do, as always, I'm going to turn off the video. And by the way, if I ever forget, if you finish your quiz and you don't hear this is now recording, tell me, please, so I don't forget. I was so embarrassed yesterday in my calculus class when I forgot, and they don't get a recording of it. So please remind me if I forget. Fortunately for you guys, I remembered. So I'm going to go to stop the share, and we're going to stop the recording.